Okay, so welcome to video lecture, chapter 16, section 9. Here we're talking about polyprotic acids. So when you hear the word polyprotic, so poly, you should think many. Right? So poly, this word means many. Protic, we think of proton, which is H plus. So a polyprotic acid is an acid that has many hydrogens. So looking at this table of Ka values, see ascorbic acid is polyprotic, H2C6O6. So it's that very first hydrogens. Remember, the acidic hydrogens are typically listed first. So we have 2 acidic hydrogens in ascorbic acid, 2 acidic hydrogens in carbonic acid. Citric acid, I've got 3 acidic hydrogens, etc. I can also tell how many acidic hydrogens we have based on how many Ka values we have. So in our previous Ka table, when we were looking at just monoprotic acids, or acids with 1 acidic hydrogen, we saw just 1 Ka value. Now looking at polyprotic acids, I can see that I have many Ka values. So Ka1, Ka2, and Ka3. If there's only 2 Ka values listed, so Ka1 and Ka2, that tells you that it's diprotic. So diprotic, because I've got 2 acidic hydrogens. I can also see if I have 3 acidic hydrogens, this would be triprotic. So that's what we're looking at there. What I want you to be able to do is write out the different Ka reactions for polyprotic acid and also understand what the numerical values mean. So Ka1, 10 to the negative third, Ka2, 10 to the negative 12th. So remember, 10 to the negative 12th is a much smaller number than 10 to the negative third. That tells you that your Ka1 value is larger. So that just tells you that the first reaction is the reaction of the stronger acid. So let's together work and write out all the Ka reactions for carbonic acid. So carbonic acid, right? So from our Chem 16, Chem 101 lectures, we know that carbonic acid, carbonate, H2CO3. So write this down. Carbonate, CO3 2 minus H, remember, became ic acid. So carbonic acid is, we neutralize the 2 minus, instead of H2CO3 and aqueous. So let's go ahead and write down our Ka reactions. So we always start your Ka1, you always start with a fully protonated acid. So that would be fully protonated, the H2CO3, and it's an acid, so it's aqueous. And remember, a Ka reaction, you're always reacting an acid with liquid water. And I know this is a weak acid because I've got Ka values listed, and it's not one of the 6 strong that I've memorized. So I make HCO3 minus aqueous plus H3O plus aqueous. And so I can see my expression for Ka1 is bicarbonate, HCO3 minus, times hydronium, divided by H2CO3. Right, we leave out liquid water. Let me fix that. So that's my Ka1 reaction. So Ka1, I'm going from the neutral, so there's no charge here, to the -1 ion. Now let's look at Ka2. So Ka2, Ka2, I start with the acid, or the conjugate base that I just produced. So I start with this species right here. So I have bicarbonate, HCO3 minus, aqueous, plus H2O liquid, and equilibrium with. So now this is an acid, right? Acid and base. So I'm going to form the conjugate base, CO3 2 minus, plus the base turns into the conjugate acid, H3O plus. And these are both aqueous. And now my Ka2 reaction, or Ka2 expression, products over reactants. So I've got carbonate times hydronium divided by bicarbonate. Again, not including liquid water because it's a liquid. So what I notice, my Ka2 reaction, I'm forming the 2 minus ion from the 1 minus ion. So what I want you to be able to do is be comfortable writing all of the different Ka reactions for a polyprotic acid. So again, Ka1, we start with a fully protonated acid. Again, there's no charge here. We're forming the 1 minus. So let's go ahead and add our acid-base conjugate pairs. So I know this is my acid reacting with water as a base. So the acid becomes the conjugate base because acids lose a proton. And the base turns into hydronium, conjugate acid, because remember our base gains a proton. So you're transferring a proton from the acid to the base. And let's talk a minute about the numerical values. So for carbonic acid, I can see my Ka1, 4.3 times 10 to the negative 7th. And my Ka2, 5.6 times 10 to the negative 11th. So I can see that my Ka1, it's always going to be greater than Ka2. That tells me that carbonic acid is a much stronger acid than bicarbonate is. They're both weak acids, but this is the stronger of the two weak acids. This would be a weaker of the two weak acids. I know these are both acids because I've got Ka reactions for both of them. Okay, so let's go ahead to the next slide. And so I want to do another practice problem, write all the Ka reactions for phosphoric acid. So I'm going to set this up for you, and I'm going to have you pause it and write this, and come back and check your work. So again, phosphoric acid, ic used to be 8. Phosphate is PO4 3 minus. So phosphoric acid, H3PO4. So what I want you to do is to write your Ka1 reaction, Ka2 reaction, and Ka3 reaction. And remember, Ka1, we start with H3PO4 aqueous plus H2O liquid in equilibrium with, and you write your acid reactions. So this is your acid, this is your base. Remember, the acid is going to lose a proton, and your base is going to gain the proton. So go ahead, pause the video, write out the 3 Ka reactions, then go back once you're finished with that, hit play again, and we will go over these together. Okay, so thank you for pausing and working out this problem. We're going to now go over this together. So I know my phosphoric acid is the acid. It's going to lose a proton. So the conjugate base is going to be H2 PO4 minus aqueous plus my base gains a proton, turns into H3O plus. And then let's go ahead and write my Ka expression also. So Ka1, products over reactants, H2PO4 minus times H3O plus divided by H3PO4. Okay, that's my Ka1 reaction. And again, notice Ka1, I go from the fully protein, so charge of 0. I know it's a charge of 0 because there's nothing written there, to -1. Now let's look at my Ka2. So Ka2, I take the species, the conjugate base that was just formed, and that's what I write as my reactant. So I start with H2, H2PO4 minus plus H2O liquid in equilibrium. So acid, the conjugate base is going to, remember acids lose a proton. So I form HPO4 2 minus plus water is my base. Bases gain a proton, so make H3O plus, which is the conjugate acid. And my Ka2 expression is going to be HPO4 2 minus times H3O plus divided by H2PO4 minus. And now I see my Ka2 reaction is going from the -1 to the -2 ion. So now my Ka3 reaction, what am I going to start with? Well, you're going to start with the conjugate base that was just formed. So I'm going to start with H2PO4 2 minus aqueous plus H2O liquid in equilibrium with, oops, I made a mistake. So where's that mistake? So again, I'm needed to start with what I made, HPO4 2 minus. I have an extra proton, so that's a mistake. Let's go ahead and erase that. And now I have H. So HPO4 2 minus in equilibrium, and I'm forming PO4 3 minus plus hydronium, both aqueous. So again, I have my acid donating a proton to make the conjugate base, so losing a proton, and my base forming the conjugate acid, so gaining a proton. My Ka3 expression is phosphate times hydronium divided by HPO4 2 minus. So with this, I can see I'm going from my, so for the Ka3, I'm going from the 2 minus to the 3 minus ion. So again, what we went over in this extra practice was how to write our different Ka values. Ka1 going from the neutral to the -1 ion. Ka2 going from the -1 ion to the -2 ion. Ka3 going from the 2 minus to the 3 minus ion. So hopefully this was good practice. You'll have additional practice problems on your ALEX homework as well as some practice exams.